Ladies and gentlemen, boys and girls, Algebra 2 fans of all ages, welcome to Unit 7, Days 3 and 4 notes. The last notes video that I'll be doing for this school year. Yeah, so Unit 7 is the end of Semester 1 Algebra 2. I hope that you're excited to get this last little piece of knowledge under your belt. Let's get right to it. Okay. So we're going to have, between the 2 days, we're going to have a total of 5 topics, right? So the first topic is called How the Leading Coefficient Affects the Shape of a Parabola. Now, a coefficient is the number in front of a letter, in front of a variable. So if it gives you this A and it happens to be a number, it could be any number, 2, 3, 8, -7, 1/2, -1/3, whatever. If they put a number in front of x squared, okay, x squared by itself is a parabola. Any number put in front of x squared is going to affect the shape of the parabola. So let's go over what those effects are. So first, a positive coefficient. So if a is bigger than 0, so like 2 or 5/3 or 8 or 3. If a is larger than 0, then the graph opens up. If a is negative, so a is less than 0, it opens down. As the coefficient a gets closer to 0, it's almost like the questions that you talked about in Algebra 1, where we talked about slopes. A 0 slope was horizontal. Well, if you think about a parabola, okay, the closer your A gets to 0, the more your parabola starts looking like this slope of 0. Right? So what does that mean? It means it's going to get wider. So we're just going to write wider. And then the further away from 0 the slope is going, okay, or the A is going. Okay. What's further away from horizontal? Well, it'll be like vertical. So it could get closer and closer to just a straight vertical line, right? So we would call these narrower parabolas. Okay, so we could say narrower or more narrow, okay, whatever you prefer there. So I'll put narrower, narrower. Okay, so as we look at these graphs down here, the narrowest graph will be the graph whose A is further from 0, and the widest graph, this is the widest one here, is the graph that's going to be having the A closest to 0. Okay, now there will be questions like this one. Choose the coefficient with the least value. So the least value, right, that takes you all the way back to pre-algebra. The least value, okay, if you have a number line, the least value, okay, on a number line is the number that is furthest to the left. Okay, so if you have any negative numbers, obviously the negative numbers have a lower value than the positive numbers. So the least value is the number, the A, that is furthest to the left on a number line. Number line. Okay, so if you had a number line, okay, and you had like 3, 1, -1, -5, okay, the least value of all of those would be the -5 because it's the furthest to the left. I'm going to leave that number line there, and let's talk about the greatest value. The greatest of these four values is the one that's furthest to the right on the number line. So in this case, it would be the 3. Okay, so it would be the greatest value is the furthest to the right on a number line. Okay, so with that information, let's tackle this ALEKS question right here. Let's do example 1. All right, so it says for each coefficient, choose whether it is positive or negative. All right, so for the coefficient A, this one right here, ax squared, this is a happy face. Happy people are positive people. Okay, so it's positive because your parabola is facing up. It's with, like it has a big smile. Okay. B, again, it's facing up. It's concave up, we say. So it's a positive A. There's going to be a positive number in front of the x squared. For C, it is facing or concave down. It's open down. So that is a negative A for that equation. Okay? And then D as well, it is concave down, so it is going to be a negative little a value. Okay? So the negative coefficient, A is going to be less than 0 if it is concave down, or it opens down. Okay, so let's go to next question, question B. Question B says, choose the coefficient that's closest to 0. Remember, closest to 0 is closest to a horizontal line. So up here, closer to 0, it's wider. So what is the widest? It doesn't matter if it's facing down or up. What does matter is how wide it is. Okay, well, I think that you can see just by looking at these that this one is the widest of your graphs. So that would be the A graph, okay, graph A. Now it says choose the coefficient with the least value. All right, so least value. So remember that up here, least value is the value that's furthest left on a number line. Okay, so first off, is it going to be positive or negative? For least value, it's always negative. So we know it's not this one and it's not this one. All right, now up here, when we looked at the number line, we said, well, -5 is further to the left. So it is a least value answer if these were your four options here, the -5, -1, 1, and 3. Okay, so -5 is further from 0 than -1. So therefore, -5 is going to be narrower and down. So when they ask you about the least value, you want to get the graph that is opening down, if they give you one, that is the narrowest, further away from 0, right? So that would be this one right here. It's narrower than D, so it's more negative. Okay, so that would be choice C. And there we have it. Okay, go back, fast forward, rewind, pause, whatever you need to do, but make sure that you get that, that topic down pat. Okay, that one could take a few minutes. Great. So let's scoot down to question number 2. And this is the other type of example you'll find on ALEKS for this topic. This time they don't give you graphs. They just give you the equations. Okay, so they give you the numbers that you are going to be able to to use in order to answer the questions. So let's look at A. A says for each function, state whether its graph opens up or down. Okay, so what is in ax squared? What is the A for this one? Well, what's in front of x, okay, or in front of x squared? There's a negative, so it's a -1. So because it's a -1, it is facing down, or it opens down, concave down. There's a -2. So because the A is -2, it's again open down. -3/4. We got a third one that opens down. +2/3. Well, that one obviously is opening up because the A is positive. Okay. Place an X for the function with the widest graph. So widest. Remember, how do we get wide graphs? The A must be the closest to 0. Okay. So what is closer to 0? Okay, so this A is -1. This A is -2. This A is -3/4. And this A is 2/3. So which of these numbers is closest to 0? Well, I hope you can all appreciate that both -3/4 and 2/3 are closer than 1, and it's closer than 2 as well, right? So as far as which one's closer to 0, it's got to be the fraction between 0 and 1, okay? So which of these two is closer than the other? Well, 3/4 is closer to 1, so 2/3 is closest to 0. Since 2/3 is closest to 0, that's going to be the fattest or the widest, right? And it said to put a big X there, so that's what we're going to do. All right. Place an X for the function with the narrowest graph. Well, let's go back to the top of the page and look at the narrower graph. When is a graph narrower? When the A is farthest from 0. So out of these 4 A's, I hope you can tell that -2 is the farthest from 0. So I'm going to put a big X right there. Okay. And that's it for that page. Yippee, let's flip the page. Okay, so now we're going to look at using ALEKS tools to transform graphs of quadratics, which look like parabolas, cubics, which look like little, I don't know, kind of squiggly lines a little bit. They start down and they go up, or they start up and they go down, and they usually have a little hump in the middle. Square root, which you've looked at before, and absolute value, which looks like a V. Okay, so we're going to do all of these transformations that we've worked on, and we're going to use the ALEKS tools to do that. All right, so we're going to list these steps. For example, 1. What I'll do is I'll screen share an ALEKS question to help out a little bit as far as being able to see me actually do one of these questions, or at least show you all of the different tools. Like this tool right here will move your graph right, left, up, or down. This tool right here will stretch or shrink vertically. This tool right here will stretch or shrink horizontally. This tool right here will reflect over one axis, and this tool right here will reflect over the other axis. And these are all the tools that ALEKS will give you to create your new graph. So let's do this. Let's fill in these blanks first. All right, so this, they already gave it to you. So remember, if inside with the X, it says -2, for example, you're going to go 2 units to the right. If it says +2, you'll go 2 units to the left. Outside of the parentheses, if it says -2, you go down. If it says +2, you go up. All right. Now, if there is a number outside of the f of x, okay, if there's a number outside of the grouping symbols with your x, okay, it's outside, so it is going to be multiplied by your y coordinate, right? We did this in the previous notes. Okay. Horizontal, if the A is inside the parentheses or the grouping symbol, whether it's square root or absolute value, whatever the grouping symbol is, if it's inside, it acts on the x. Just remember that it is going to be dividing the x coordinate by that A, okay? Now, when the negative is inside the grouping symbols, whether it's the square root or the absolute value or parentheses or whatever it is, if the negative is on the inside, it changes the sign of x. And when you change the sign of x, you reflect over this guy right here, which is the y-axis. Okay. Conversely, if the negative is outside of the grouping symbol, you're going to change the y-coordinate and you're going to reflect over the x-axis. Okay, so let's look at the steps that you would take if you started with x squared and you are going to now make it into y equals negative 3x squared plus 4. Now remember last time we talked about following PEMDAS. Okay, the last set of notes we did. We don't have any exponents that we have to worry about as far as transformation. These don't ever raise anything to a power, but we do make sure we take what's in the parentheses first. Okay, in this question, there's no parentheses with the x, so we don't have to worry about that. Then you would multiply and divide. All right, now all we're doing is listing the steps. We're not graphing it yet. Okay, I'll show you in a minute here how to do that on ALEKS. But the first step would be to look at when you multiply and divide. Okay, there is a multiplication of a negative symbol and a multiplication of 3. Right, so we would take that 3, we would, what would the 3 do? The 3, remember, if the 3 is outside of any parentheses, the 3 is not in the parentheses, but it is being multiplied. We would multiply the y coordinate by a, and we would make it stretch. So we would do a vertical stretch by 3. Okay, next thing we would look at is that negative symbol. Okay, if there's a negative, again, it's not inside of any parentheses or grouping symbol with the x. It's outside with the y. So what we would do is we would change all of the y coordinates, which would reflect over the x-axis. Okay, now there's one more thing that was not in the original. This is the parent graph. All right, so we took care of the 3, and we took care of the negative, but there's this plus 4. Okay, the plus 4 is not in grouping symbols with the x. It is outside, and that means it's either going to go up or down. Well, plus 4 means I would translate my graph up 4 units. Okay, let's scoot down and do the next question. Okay, so we're down here to question 2. So what was not in the parent that is now in your graph that you're going to have to create? And remember, we go with P, there is no E, and then we'll go MD, then we'll go AS. Okay, so in the parentheses or in the grouping symbol, well, the grouping symbol is this square root symbol. So in the square root, there is something there. There's a -2. So if the minus is in with the x, then we're either going to go right or left. Okay, so because it's minus, first thing we're going to do is we're going to go right 2 units. Okay, the next thing Okay, so in the parentheses, we're done with those. Parentheses done. Multiplying and dividing. Well, the only multiplication is that 1/2, right? So the 1/2, notice it's not inside the square root with the x. Okay? It is outside. Or is it? Where is it here? There it is. It is outside, right? The a is outside of the f of x, or of the square root. Because it's on the outside, it is going to be either a vertical, stretch, or shrink, right? Now, this is a 1/2, so anything between 1 and 0 is going to shrink, right? So this is a vertical shrink by 1/2. Okay, now if you're confused on this, or you think that this is a bit much, wait about 2 minutes. When I do this on ALEKS, you're going to immediately say, oh, wow, that's not too bad after all. So just relax, okay? Keep with it. We're going to make sense of it, and then I'll show you on ALEKS how to do this. Now, finally, there's a +1, adding and subtracting. So we did the multiplying. All right, so now the add, subtracting. Now, again, the adding here is outside of the grouping symbol. So because it's outside, we are going to go either up or down. Now it's a plus, so we're going to translate everything up 1 unit. Okay, so now here's the teacher reminder. Okay, I'm going to log into ALEKS, and I am going to try to show you here just how easy these questions are in ALEKS. Okay, check this out. All right, so what I've done here is I've created a student view in my ALEKS. So I'm just going to do a couple of questions here with you, just to give you a for instance. So here are a couple of ALEKS questions, and what I can walk you through here. For example, let's look at B here. Okay, it gives you this graph, and there's like this upside down V, and it says that is y equals h of x, okay? And that's fine. Now what it wants you to do is it wants you to draw a graph where you took h of x and they put a negative in front of whatever's inside the parentheses, and then they did a -2 outside, okay? So if we remember PEMDAS, anything in the parentheses, we have to do first, all right? So in the parentheses, there is a negative with the x. So we would change the signs of any x's. So that's the first thing we would do, okay? So let's look at this point right here, 2, 4. Change the sign of that x. It would go from 2, 4 to -2, 4, okay? So we have the negative taken care of, and why don't we do all 3 of them? You don't have to do them out quite like this if you don't want to, but that's okay. All right, so if I change the sign of the x for this point, 0, 0 is going to stay 0, 0. And then if I change the sign of x for this point, it goes from 4, 0 to -4, 0. So there's the 3 points. And you can see that if I connected the dots, it would be a V, upside down V, that was reflected here over the y-axis, okay? So it's reflected over the y-axis because we changed the sign of the x's. Okay, so now the last thing we need to do is take care of the -2. We took care of the minus in front of x, the negative. Now we're going to take care of the -2. It's outside of the parentheses, so we're just going to go down 2 units for each of these points. So let's take this point up here. Let's drop him down to 2 units, which means we're just going to subtract 2 from the y. We're going to do the same thing with this point right here. Drop it down 2 units, again, subtracting 2 from the y. And then lastly, we'll take this guy right here, drop it down 2 units. Then we can go ahead and make each of these line segments. Boom. Okay. So hopefully you can see right here that we took the negative, which reflected over the y-axis, and then we went down 2. Okay? So there's an example of that type of a question. Let's jump over to question 6 here. All right, so this one's a little bit more like what we just did. Okay, here, again, we're going with PEMDAS. We have these 5 tools. So this tool will move, it'll translate left, right, up, down. So let's say there was a, there isn't, but let's say there was a -4 out here. So we could just take this and go down 4 units. Okay? You might want to grab it right by this dot. Okay, so let's say it was a +5. We would go up 5. Okay, if you ever want to go back to the original, just hit the X. All right, so what are we going to do here? PEMDAS, inside of the grouping symbol. These absolute value brackets are your grouping symbol. So what do we do first? We take care of the +3. If it's in the grouping symbol, we're going left or right. If it's plus, we are going to the left. So the +3, I would first say I'm going to translate, which means left, right, up, or down, and I'm going to drag it 3 units to the left. Okay, so the +3, done. Awesome. Okay, now what's left? There's a minus and a 2. They're both multiplication, and they're both outside of the absolute value brackets, so they're outside of the P in the PEMDAS, outside of the parentheses. So what does the negative do? Let's take care of the negative first, right? The negative is outside of the absolute value, so it changes the sign of y, which reflects it over the x. So I'm just going to hit this button, boom, and that changes all of the y coordinates, and it reflected it over the x. Now, if the negative had been inside with the x, if it had been -x, I would have done this guy here, right? It didn't, so I'm just going to put it back, right? So this is reflecting over the y-axis. This one reflects over the x-axis. And now finally, there's a 2 out here. We took care of the +3. We moved it left 3. We took care of the minus outside of the absolute value brackets, and we reflected over the x. Finally, there's a 2 out here. So outside of the absolute value brackets, outside of the grouping symbols, we are going to vertically stretch or shrink. So that's going to be this guy. Okay, there's a 2. So notice that from the beginning, they went over 1 and down 1. Instead of 1, we're going to go down 2. So we're going to double it. And that's it. We're done. Okay, so if I wanted to check this one, hopefully it's going to tell me that it's right. Hey, what do you know? We got it. Cool. So that's what each of these looks like. I'm not going to do another question out. We'll just play with this for another second. Let's look at question 5. So again, this symbol right here, this is going right or left or up or down. Okay? So this will take care of this +1 and this +4. Okay? So it'll get you somewhere there. So wherever you go with that, it doesn't matter. Let's say we go over here. Okay? This symbol reflects over the y-axis. Okay? We will use that when there is a negative in front of your x inside of the grouping symbol. If there were a negative outside the grouping symbol, we would reflect over the x-axis because it would change the y coordinate. Okay, so we could do that. This right here, this is the horizontal stretch or shrink. If inside of the parentheses there was like a 2 in front of the x, then we would take whatever direction we're going and we would we would double it. Booyah. Okay. All right. So, okay. All right. Oh, I'm sorry. That would be a dividing by 2. So if it was a 1/2, we would divide by 2. We would double it. Awesome. Cool. All right. Now, the one that you'll find more often is like this 3. Now, if this 3 were in front of this particular parabola, instead of going down 1, we'd go down, or we got to go down 1, 2, 3. Okay, you would triple it. Instead of 1, it's 3. So notice when I was doing this here, if I try going up or down and I have the wrong button, it won't let me go up or down with this guy. If you want to go left or right, it won't let you go left or right with that guy. It only goes up or down with the vertical shift, with the vertical shrink and stretch. This guy here, it'll only go left and right with the horizontal shrink and stretch. Okay, so that's just a quick little tutorial on these. If you want to undo your last move, you hit this button. If you want to go straight back to the beginning, you hit this button. Okay, so I'm going to unshare this screen, and we are going to go back to the regular notes sheet. Okay, so the day 4 section of our day 3-4 notes. This first real world situation topic, I think you'll find this pretty simple. It's basically taking Algebra 1, combining like terms and applying it here. So let's check it out. All right, Alan and his wife are starting savings plan. Alan is going to set aside $650 and then add $165 every month. And it'll look like this, because the amount A in dollars that he saved is going to be $650 plus 165 times n, which is the number of months. Cool. So we've got this first equation for how much money Alan is going to be saving. Now his wife is not going to start with an initial amount. She's not going to start with like that 650. She is just going to set aside $395 every single month. So $395 every month, $395 times the number of month, and they're just going to call it B, just because they just used A for Alan. All right, so maybe his wife's name is Betty. Who knows? All right, so you got an A equation for Alan's savings, B equation for his wife's savings. Now it says let T be the amount saved using both of them. Well, that's easy. It really is. So the total is going to be the amount Alan saves plus the amount his wife saves. Okay, that's pretty easy. So now it says we are going to combine them, which we just did with addition. And then it says write an equation that relates T to N and simplify. Okay, so we just have to substitute what A equals, and we have to substitute what B equals. Easy peasy, or as some of you like to say, this is light work. All right, awesome. So here's your light work. A is just 650 plus 165 N. How do I know? Because that's what it says A equals right there. So we put it right there, okay? Plus B, and it says B is 395N. Okay, that's not difficult at all. None of you, I'm sure, think that's difficult. So now you just go back to your Algebra 1 days and you ask, which of these terms are like terms? Well, the like terms are the terms that have the same variables that have the same exponents. This has n to the first, this has n to the first. I can combine them. It's positive 165n plus 395n. Great. So my answer is, okay, the 650 stays 650 because nobody did anything to the 650. We didn't combine that with anything. Plus 165 plus 395 will give you, what, 560? N. That's your answer. That's your first topic there. That's it. Don't make it any more difficult than it really is. Okay, you take the first equation and you take the second equation and then just read what they want you to do. Okay, they want both plans combined, add the two plans together, add the two equations together, add your like terms, combine your like terms, done. Okay, let's go to the next topic. And this is our last page of the year. Don't shed a tear. I'm not crying, you're crying. Or is it the other way around? Okay, so we're going to take the sum, which means you add, the difference, which means you subtract, and the product, which means we multiply, of two functions. We're just going to add, subtract, and multiply some stuff. That's it. So let's look at this question here. We start with number 1, and it says r plus s of x. Well, you remember the distributive property? It's not really like that, but it works out that way here. This is, you take r of x plus s of x. So what is r of x? It's 3x. Plus s of x. S of x is 2x squared. And now you just have to ask if there are any like terms that you can combine by adding or subtracting. 3x and 2x squared are not like terms because one has an x, but the other has an x squared. So therefore, they don't have the exact same variables with the exact same exponents. They have the same variables, but not with the same exponent. So you can't combine any like terms. You're done. Nice, right? Okay, number 2, f minus g of x. Okay, watch this one. F minus g of x. So f of x, now because there's two terms, it's a binomial, I'm going to keep it in parentheses for now. F of x is 3x minus 2. Now it says minus. This is the one where you have to watch, okay? When it's a minus, that's where people are going to make their mistakes, I guarantee. Minus g of x. G of x is x plus 2. Okay, so here we go. Take care of the minus. Take care of the minus. I believe we did this, it was either at the beginning of this unit or in the previous unit. Okay, if you are subtracting one polynomial from another one, some people can say, okay, 3x minus x, easy. Minus 2 minus positive 2, easy. Other people really need to rewrite this as an addition question. But minus x is like saying plus negative x. And minus 2 is minus 2. Okay? So you take the negative, distribute it to the positive x and the positive 2, and change both signs. Okay? Change all the signs. And once you've changed the signs, now it's just adding. So we're going to take 3x, wait, I'll put them under, 3x plus negative x, which is 2x. And now we'll take negative 2 plus negative 2, and you get negative 4, or minus 4. Okay, I know that some people will do the negative 2 minus 2 and they'll get 0, but negative 2 minus 2 is negative 4, so please watch that. Okay, s times f of x. So this is s of x times f of x. So s of x is right here. It says 2x squared times f of x, which is 3x minus 2. Okay, so there's two terms here. There are two terms here because there's a minus in between the two terms. Plus or minus will separate terms. So there's one term here, and we got to multiply it by each term in the parentheses. So 2x squared times 3x. 2x squared times 3x, I multiply 2 times 3 and I get 6. I multiply x squared times x to the first and I get x to the third. Okay, you can go back and rewind that one if you want. 2 times 3, 6. X to the second times x to the first is x to the third. Okay, please make sure you get that. 2x squared times minus 2 is minus 4, and then the x squared comes along, and you have finished. Okay. Finally, f times g of x. So we take f of x. Again, it's a binomial, so I'm going to keep it in parentheses. 3x minus 2 times g of x, which is going to be x plus 2. Okie dokie. So here, hopefully, you can realize that we are going to distribute the 3x and the minus 2. Okay, this was the foiling that we did a while ago. Right, so 3x times x. Okay, if we want to take the f, the o, the I, and the L. If you don't use the FOIL, that's fine. I mean, you're just going to go through and just distribute twice anyway. Okay, so first times first. Okay, so that would be the 3x times the x. Let's go color coded. 3x times x. So that's 3x squared. Okay. Outer. So 3x times the plus 2. Right? So 3x times positive 2 is positive 6x. For the inner, the minus 2 times x. That's minus 2x. Then the last, the minus 2 times the plus 2. That would be minus 4. Now, if you remember, back when we did the foiling, we had to look to see if there were any like terms. Yes, there are. So positive 6x and minus 2x, combine them. And so you should get a final answer of 3x squared plus 6 minus 2 is plus 4x, and then bring your minus 4 down. There's that answer. Okay. All right. Last set of questions here. R minus S of 2. These are kind of cool. I like these because if I think about what is R of 2, and then I can think of what is S of 2. Well, those are easier than what we just did. Because how do I find R of 2? R of 2, I know what R of X was, so I'm just going to replace the X with 2. Well, R of 2 is 3 times 2. 6. Okay? It's just that simple. And then minus, because there's a minus, S of 2. So we go to the S function. So it's not S of X, it's S of 2. So instead of 2 times X squared, it's S of 2 would be 2 times 2 squared instead of 2 times X squared. Well, 2 times 2 squared, you square the 2 first because you do the exponents before the multiplying. You get 4 times 2, it's 8. So when it's all said and done, we found S of 2 and R of 2, and this just says subtract them, R of 2 minus S of 2. So 6 minus 8 is negative 2. Neat stuff. Okay, the last question of the year for the notes, S times G of negative 1. So like I said before, this is S of negative 1 times G of negative 1. Sweet. So what is S of negative 1? Well, let's go up here. S of negative 1. Okay, instead of 2 times X squared, it's 2 times negative 1 squared. Well, negative 1 squared, negative 1 times negative 1 is 1. So 1 times 2 gives you 2. Okay? Remember, we're multiplying. So times g of negative 1. Well, here's g. So g of negative 1, instead of x plus 2, it's negative 1 plus 2. Because we know what g of x is, we replace the x with the negative 1 to get this g of negative 1. So negative 1 plus 2, that's 1. So this comes down to 2 times 1, which you all know is 2. Okay, there it is. The year end, or the semester end of Algebra 2 Semester 1. Okay, if you have questions over this, please get in contact with me. Use these notes to do your practices and your unit review. And best of luck. Hope everybody's well. And I look forward to hearing from you and watching you all perform wonderfully on the test. I'm sure that as long as you're doing the practices and the unit reviews, you will be more than prepared. Okay, take care.